please. So 3 to the 4, I don't just want the answer, it's what were you doing. So try and beat me to the answer. Yeah, I know, 81 in the end. And the reason is the 4 there means, right, 3 times, 4 times, and multiply each one. That's the basic meaning of what an exponent is. We're still talking about the exponents that we started last week in a way, but now we're doing them in a little bit more for doing calculations. We've actually been dealing with the same stuff since we're doing percentages. So this is exponential growth and decay still. All this stuff is linked. Okay. See who can beat me with the next one. Amina, you missed a 3 multiplication out. So the next one's, yeah, 1,000. And again, the reason is you've got tens 3 times and you're multiplying. Next one. See how many get this one. Deny it? Do you need the question mark or are you certain? Oh, I like the writing on I am meant to see us. Yep. 144, it is positive. Because we've said minus 12 times minus 12. Now this one was put in as a caution. Be careful about how things are written in. That one has possibly 2 meanings. And you need to be careful, and I've got it in as a caution for calculators as well. Yeah, some of you got positive 1, some of you take negative 1. Right. It depends how what this minus means. There's actually 2 negative signs if it's clearly written. Now this long negative sign is actually a subtract 1 squared. So that would be a negative 1. Notice this is smaller and slightly raised. That's an artistic thing. It's really awkward. So if you see a question written like that, I would put a mark right next to it and say taken as being subtract 1 squared, not minus 1 squared. I'd put a note on it because that means people will give you an answer. The other thing this can be taken of is if this is a minus 1 as a property of a number, i.e. the answer to a calculation, and then you square it, that actually comes out as positive 1. Okay, so if minus 1 was a result of a calculation, and on your calculator you do the following, you've changed slightly the order of calculations. If you type minus 1 and equals, and then you go answer squared, it's doing the bracket thing from before. There's a button on calculators though that should force this to happen, and on a lot of calculators there's a plus minus button, and that's badly coded. It doesn't work. It doesn't work right in this case. Okay. If you have a calculator in front of you, I'll check which my calculator does. Where's my calculator? Apps. Yeah, Isolo?
Anna's Wi-Fi is bad, so that's why she keeps leaving.
Ionats keeps sneaking in. Okay. So hang on. Windows. I'm looking for my calculator. Maths calculator. So this is something to be very careful, particularly doing distances when using Pythagoras. If you're talking about distances going up and down, when people use this minus sign, they sometimes get it wrong. There's the negative sign on this one. So if I do negative 1 squared, this negative isn't subtract, it's supposed to be a property of the number. And a lot of calculators do that. It's taken this minus, which is the property of a number, to be a subtraction. So just be really careful about using calculators and squaring negative numbers. If you want to do minus 1 squared on a calculator, tell it, I want minus 1 that squared. Just be careful about them. Okay, that's my caution about calculators. It's one of the biggest errors I see on most calculators and people doing a partial of Pythagoras. Right, next question. Do we have the understanding of what 10 to the 0 means? Yep. 10 to the 0 equals 1. And the reason is, if you follow the powers, Noah, be careful about anything. There's one exception. What's the exception to anything to the power of 0 is 0? Yeah, 0 to the power of 0 is, depending on the type of calculation, it is a limit of 1. In other calculations, it's 0. In other calculation, it disappears off to infinity. It depends what you're doing. So the little reason for that, if you remember, if you consider your powers, what happens is we go down in powers and we've got 1,000, then 100, then 10, and then when we get to 10 to the 0, well, we're dividing by 10 each time. So this is going to be 1, sorry. Next one, have you come across negative ones? Yeah. Seeing everything coming in? Yeah, you've come across negatives by the looks of it. 10, 15. Oh, you're coming back soon, are you, Yakov? So you should be working by then. Hopefully I'll have done everything I need to. Okay, so we've done the minus ones. Everyone so far is good. I've not seen anything wrong. If you're looking at everybody else's answer and think it's wrong, do tell me to stop. Okay? So, yeah, this one is 1/5. And it's following on this pattern. When I go 10 to the minus 1, I'm going to divide by 10 again. So we take 1 and we divide by 10. So the fractional version is nicer to see. And in this case, we get 1/5. If I do 5 to the minus 2, it's 1 over 5 squared, because we've dealt with the minus first, and then 1 over 25. Okay, so they're the basic rules. And what I'd like you to think about is what happens with the index in between then. So why do these work? And my explanation to think about it is to think the index says how many of a thing to take. So if I say 9 squared, that says take 9, write it twice. Okay. The problem one though is, if I say I want to write half of my 9, what can that mean? Now there could be a couple of ways of thinking about it. One way is to go split the number into its prime factors. Prime factors of 9 are 3 times 3. And I want half of that calculation. Half that calculation is 1/3. Okay? Flash your microphones if you see that bit. Yeah? I'm going to give another explanation in a moment as well, which uses the index rules. So we can actually do more complex ones. We can say things like, what's 1,000 to 1/3? Well, what repeated calculation gives me 1,000? 10 times 10 times 10, and I want 1/3 of it. 1/3 of that calculation, 10. Yeah? Have you seen what happens when I do the base multiplication? If I do 3 squared times 3 to the 4, what's the single way of writing that without doing the final calculation? Yep, 3 to the 6. Noah, I hope you don't use that symbol when we're doing Python. Python, it's star star. Yeah? First thing to notice though is we must have the same base. And what you did with the rule index was you actually added the indices. Yeah? Let's do 9 to the 4 divided by 9 to the 3. Go on, chat them. Yeah? Andre's gone for the Python method. Yeah, 9 to the 1, which is 9. Okay, so we're okay with that rule. How about this one? 2 to the power of 3, all to the power of 2. Yeah, getting the right thing out. This 2 says do 2 to the power of 3 times 2 to the power of 3. That's what that 2 does. 2 to the power of 3 times 2 to the power of 3. We can add the indices. And that gives me 2 to the power of 6. So we're going to use this last one to explain this index rule as well. If I say I want to take 10 and cube it, I know I've got 1000. Yeah? That 10, I'm going to do it as a power where we get, oh sorry, this answer comes out as a power of 1. So what do I need to multiply that by to give me a power of 1? 1/3. What must this 1/3 be to cube to give me 1000? Well, that's going to be 10 inside here. So 1/3, that must be 1000, because these cancel. They become the 1. This part on the inside must be that 1000 again. Yeah? Flash your microphones if you're okay. So we've just looked at 2 different ways of explaining the same thing. You can use your index rules, or you can expand the number out and then say, right, how many of these things get repeated? And that's what the fractional thing does. And it also therefore means this symbol, the 3rd root of 1000, actually says which number do I multiply by itself. Three times. And that's basically, if you reverse the question, that says which calculation do I need to do a 1/3 of to give me 1000. Is 1/3 of this multiplication sum. So that's why that one works. Last example, and then you're free to have a go at all the exercises on here. Let's see how we can do 64 to the 2/3. So we need to split this into 2 bits. And there's a choice here. It's a bit like doing this bracket. I've got a choice of which bit of this 2/3 I do first. Because I want to multiply my index to give me 2/3. I could do square first and then 1/3. Or I could do it the other way around, 1/3 and square it. Be aware of both techniques, because certain questions, the cube root of the square is nicer than the square of the cube root. In this case, I hope you all realise that the cube root of 64 is 4, and we're squaring it to give us 16. The 64 squared should be 1024. Oh, 4096. Oh yeah, cube root I wanted. 4096 to the 1/3. And that does work out as 16 as well. But if you're doing it mentally, just think about that number, which bit can you do first? And oh, I know the 3rd root of 64. Yeah? There's exercises in the book on page 42, exercise 3.2. I suggest all you to show what you can do, no calculator, question 9, 10, 7 and 3 in that order, because they get a bit harder. And then have a go at question page 43, 4 or 5 questions. But make sure you show your technique, please. Okay, guys? Go flash your microphones. If you go off, you go. And I'll stop the video for that.